Okay, the third activation layer will be concluded with the help of sigmoid function at the second activation layer in form of again a sigmoid function with the weight parameters. So in such a way that for the initial benchmark features of the second layer, the weight parameter for the first feature set to the second layer, weight parameter for the second features of the second layer, weight parameter for the third feature of the second layer with the third features of the second layer. So all these will be summed out and we will get the output in form of a third activation layer. So let's see how we can apply the logic gates on it. In case we are considering the two simple features, x1 and x2, and of course we need to apply some kind of a logic gate and logic gate. This AND logic gate basically follow the system of electric circuit, and this electric circuit system work in form of you can say that the series data. If there is some circuit, this is some kind of a switch. Again, there is some kind of a switch in a series. So there is a suppose bulb, and there is some, you can say there is some battery. Okay. So if we want to turn this bulb on, we need to connect. Okay. First we need to, okay, let me make a truth table. Important thing, we also need to check how many features are there. There are two possible features. We need to apply a formulae, this formulae, and represent number of features. If there are two possible features, we need to consider this, and we will get 4. So 4 possible choices, 4 possible possibilities are there. So in this situation, our hypothesis functions can be configured in such a way that, of course, this is somehow follow the sigmoid function. And first case, both are in off position. So x1 is 0, this one is x1, this one is x2. Both are in 0 off, okay, not connected. If x1 is connecting, we are connecting x1, but not x2. x2 is again 0, and we are, okay, first both are in off conditions. Output will be what? Okay, we can also consider the initial biased weight. This is the x naught, and as I already explained, this x naught equivalent to 1. This 1, and the here weight parameter in case of AND is, okay, somehow you need to consider it of very less amount. It should not be of okay. So this is our standard you can say initial features. Usually it is equivalent to 1. In this situation, in AND gate, we need to consider the weight parameter is a heavier one, for example minus 30, and here we can consider the weight parameter equivalent to 20, and for both the feature 20. So for the first expression, we need to apply some kind of a sigmoid function, as of course it is, we need to substitute all this data over here 1 plus, so we will get the desired result according to it. If both are in the on case, our x1 x2 will be okay here. In this situation we will say theta naught x naught plus theta 1 x1 plus theta 2 x2. We will get our output. In this situation, once our weight parameter minus 30, here 20, here 20, and what is the x naught is 1, and what is the value of x1? In this case, x1 0. What is the value of x2? 0. So whatever the output value, we need to substitute in here, and we will get our output. And of course both the switches in off conditions, so electric bulb will not glow, so output is almost equivalent to 0. Similarly, if we are connecting the one circuit, one switch, in a circuit one switch is connecting, another is still open, so here we are writing 1 and here is the 0. So again we need to apply the weight parameter in it. In this situation, our this x1 will be equivalent to 1, and we will get the values with these values. By substituting these values, we will get 0. The bulb will not glow. If our first, in case we are only connecting the second switch but not the first one, second switch is connected but the first switch is unconnected, so again we will substitute the value here, and we will get output in form of 0. If we connecting both the switches, then our circuit will be complete. Then our this sigmoid function, by substituting the value here, we will get answer in form of a 1. Then our bulb will glow. So this is the example of our first logic gate, that is the AND logic gate with the possible values of the boundary values 0 and 1. We can proceed to the next. In mathematical notions, this hypothesis x1 AND gate is also expressing this one in terms of discrete structures or mathematical language, but the main theme is this: we apply sigmoid function by considering these possible inputs in terms of boundary value, and by substituting these weight value here. Remember, in AND case situation, we are giving the this negative weight in a heavy amount to the initial, because we are diminishing the effect of the benchmark data. So in order to, because we want to keep it off, we want to keep it off. So this one is the heavier value, and in order to turn it on, both the switches should be properly connected, then bulb will glow.